Hello. Today we are going to be talking about our new topic, which starts in modules 17A and 17B. And I'm going to be kind of talking about those two modules together. They will introduce what we talk about in this next unit and a really big part of statistics. And that part is called hypothesis testing. And this is done a lot because we want to see if things should change or not change and so forth. So I'm just going to first of all kind of do some definitions. So a statistical hypothesis, first of all, what that means, what that is. And it is a statement or a conjecture, make sure I spell these right, about a population parameter. And one thing is that this statement may or may not be true. May or may not be true. Okay, kind of remind us some of the parameters that we have seen so far. And remembering that a parameter is like a measurement on our population. So we have seen this guy, which we remember, hopefully, is the mean of a population. We have seen this guy, which has shown up before, and that is the standard deviation of a population. And we have seen in the last section this P, which was our proportion of a population. Okay, and a statistical hypothesis is just some statement about these things. You know, I might say that the average GPA at Western is 2.15. Okay, since I'm talking about all the students at Western, that would be my population. I'd be talking about the mean. Or I could say the proportion of students that eat popcorn on Friday nights is 16%. There I'd have some sort of statement about our population proportion. A hypothesis testing is taking these a little bit further. Is a fundamental concept in statistics. And it is done all the time up at like places like Mayo Clinic. In fact, I did do a summer internship up there in their data analysis department. And that's when I realized I did not want to become a statistician. I sat on my butt all day, so I did not want to sit in front of a computer all day. I wanted to be a little bit more active than that. So that was just me. It was not something that interested me. So first of all hypothesis tests answer the same question. And the question that it answers is there enough evidence given by some sort of sample? Let me slide this up here. Given by a sample to support a conclusion that A characteristic of the population is different somehow from a hypothesized value. That is the question that we're going to be asking. We are not going to be the ones actually designing the experiments to gather the information. We're just going to learn how that information is used. Granted, you guys will never probably do this in your lifetime, but you will see the results of these things, and hence it's nice to know where this stuff kind of comes from, what this stuff means. And I'm going to show you two methods once we get into it, which is not going to be in this lecture, but probably the next one, as to how we go about actually doing these testing. But the first thing we're going to have to talk about, though, is there are two pieces that go into this hypothesis testing. And these two pieces focus on, or are called, the null hypothesis and I like to think of the null hypothesis as what we kind of believe is the case to begin with. And the notation that we use for the null hypothesis is H for hypothesis, and then we put the number 0 down there for meaning null or empty, or the start. And the other piece that we're going to talk about today is that alternative hypotheses. And the notation that we will use here is H with a little a underneath it. Some textbooks will use a capital A. Our textbook likes to use a lowercase a. Other textbooks also use other things. So if you pick up another stats book, you might see a capital A. I've also seen a 1, so 0 and 1. The null alternative, I'm guessing they use the A because it's the alternative type of situation. These will be mathematical statements, so, and they will have the parameter that we're looking at in them as well. So I'm going to go through some examples, and hopefully we can kind of understand this null hypothesis and this alternative hypothesis. And then we'll build on that a little bit today as well. So let's just jump into an example. And let's say we have a researcher thinks that if expectant mothers use vitamin pills, the birth weight of babies will increase. Currently, the average birth weight is 8.6 pounds. And I'm making these numbers up, so I don't know if it's really 8.6 or not. Okay, and we want to talk about our null hypothesis and our alternative hypothesis. So we're going to start with kind of the null hypothesis, and I'm going to look at that based on what is currently the case. And currently the case, the average birth weight is 8.6 pounds. So average does indicate to me that we're talking about the mean. And we are going to be talking about the mean of our population of all babies being born. And currently we think that this is 8.6 pounds. I will put in parentheses here just to kind of help you remember that this first statement is always going to be an equal statement. Is always an equal statement of some sort. So what we will see is some sort of parameter, in this case our mean. We might be talking about proportions. If we were talking about proportions, we would see a p. Those will be the only two cases we're going to talk about in this class. But in the real world, we could talk about our standard deviation, we could talk about our variance, we could talk about other different measures of stuff as well. But in this class, we're going to concentrate on just the mean and our proportion. Now, our alternative is kind of what that person believes would be the case. So this guy believes that, or he expects, that the baby's weight is going to increase. So in other words, he expects that this mean is going to be bigger than this 8.6, because increase means more than. Okay, this alternative has three choices, three options. We will see some sort of our parameter, whatever it happens to be. In this case, we're using the mean. We could see a less than some sort of value. We could see that parameter being greater than our number. Or we could see the parameter not equal to 8.6. And I'm going to go through some examples on when we would get each. To kind of finish this kind of problem off, we're going to look at where we're headed. And in this case, we are looking at, or will be looking at, either the normal curves or our t-distribution curves, which are still Bell. And we know that our mean is in the middle, so our mu is sitting in the middle there. And right now we think that this is 8.6. So if I'm thinking that we're going to be bigger, we're going to be looking up at this end here somewhere. So we're going to be bigger looking this way. When we're looking bigger, we think of this as being a one tail. And in this case, we will call this actually an upper tail, because we're looking in the upper direction. Other textbooks will refer to this as a right tail, because it's on the right side. So depending on how you read this, you will have a one tail, because we're looking one direction, and we're looking to the upper side or to the right of our value. In these cases, when we have that strict inequality, that's when we will see our one tails. This guy here is going to give us a two tail, and I'll show an example of that when we get there. Don't know what I have next, but we'll see. Let's go with, maybe I'll do all three so you can kind of see. So let's look at the lifetime of a light bulb. I think we've done light bulbs in the past. And I like light bulbs because usually don't hurt anybody's feelings by talking about them. So, lifetime of light bulbs. Okay. And let's just say that these light bulbs are said to last, or whatever light bulbs we're talking about, on average 1,000 hours. Okay, and we may have that. I'll do a couple different situations. So the first situation is we may have a customer or consumer research firm believes that the light bulbs do not last that long. Okay, so we're going to actually look at our situation. So in this case, our null hypothesis is going to be that our average lifetime is that 1,000 hours, versus the alternative is he thinks they're not going to last that long, so not as long means less than that 1,000. So those are our two hypotheses. And so if we're looking at our pictures eventually, here's my 1,000 sitting in the middle, there's my mean. We're going to be looking less, so we're going to be looking down this way. So again, we will have a one tail, and we will call this a lower tail, lower tail. Other textbooks will call it a left tail. But it is a one tail, which is left. With this same lifetime one, so we can see the not equal to, our second case could be that a firm thinks the average lifetime is not 1,000 hours. So they just think it's something different. They're not saying it's longer or shorter, they're just saying it's different. So in this case, our mean is still going to start with what we kind of believe, or what is the general knowledge to start with. Our alternative would be not that, so we'll do that 1,000. And where we'll be going with these, here's our 1,000 sitting in the middle because we base and draw our pictures based on what we have in the past. It hasn't been proven that this is true yet. And since we don't really know if we're going to be bigger or smaller, we're going to look on both sides. So in those cases, we will say that we have what we call a two-tail. So that's going to be our two-tail situation. Okay, just to get a list of some words that'll help us determine what we have, I kind of want to create a list of some of the words that we might see to represent some of these symbols. So this greater than symbol, we could see the words greater than. We could see the phrase more than, increased or increases, heavier, larger, longer, bigger, higher than. When we talk about time, we kind of have to be a little bit careful because faster and slower kind of look different. So just kind of be aware that when we're dealing with time, you want to kind of watch for those things. This is less than, lower, smaller, below, decreased, shorter, I don't know, lighter, whoops, lighter, lighter, okay, and that not equal sign is going to, like in the last one we saw, not equal to, or we might just say the word, hear the word different, or different from. Might see that word from with it. A lot of times it'll just will change. Not the same as. So those are just some words or phrases that kind of hint towards one of those three symbols that we're going to see in this piece. In the real world, what happens? So let's say we have this situation, going back to our piece here, and we have this firm that believes that it is actually less than. What he's going to do is construct some sort of study. My guess is he'll gather a bunch of light bulbs and see how long they last. And based on that sample, he will determine if this is true or not. Okay, and that's where we're going to be going, is trying to figure out how do we determine if this is true or not, or do we stick with what we kind of already know? So that's what's to follow in the next section. The next section we will take very slowly. I'm going to kind of do just one sample video so that you can get very comfortable with them, going through them in great detail. Maybe two example videos we will see and go from there. But this is just a brief introduction. This is going to be just the very first touch. I will have a homework assignment out there from these first two sections for you, and then we will move on and go from there. So I will see you in the next video, and have a great day.